This is what we've been waiting for. This is what we've been doing all this pre-work to get to. We want to solve right triangles. Solving right triangles is finding every piece of that right triangle. It's 6 things, 3 angles and 3 sides. Most of the time, you're going to know at least one angle because you're going to have that 90-degree angle, and you're going to have at least 1 or 2 sides, depending on what they give you other than that. Okay? So, here is one way. You'll notice you have 5 and 7.5. So your first method, you could use the Pythagorean Theorem. That's usable. You can do it. Here's what it would look like. 5 squared plus 7.5 squared equals CA squared. 25 plus 5 squared, 7.5 squared, which is 56.25. Let's just cut out that in-between step. Got to erase each piece individually. So that's 56.25 is equal to CA squared. 81.25 is equal to CA squared. So we'll take the square root of 81.25 and get approximately 9.01. That's one way. It works. Sometimes, if you don't have both sides, it doesn't give you quite as good of an answer. So if you would have found one of the sides and you would have rounded it, it could give you a less reliable answer. But that doesn't keep us from solving for that third side in a different way. If we go ahead and try to find these angles, let's find the angles first, and then I'll show you the other way to do the sides. If I'm going to find angle A, I have the opposite side, I have the adjacent side. So the tangent of angle A is equal to 5 divided by 7.5. If you see what's going on here, remember, we talked about inverse trig ratios last video. So if I take the inverse tangent of 5 divided by 7.5, this is going to give me angle A. Well, what that gives me is angle A approximately equal to 34 degrees. That's good for us, because if angle A is 34 degrees, end up looking like a 9. If angle A is 34 degrees, I can do 90 plus 34. I subtract that from 180 and I end up with 56. Well, that means this is going to be 56 degrees. The other way that I could do this would be to say inverse tangent of 5 divided by 7.5 is 34 degrees. Then I could say the sine of 34 equals 5 divided by CA, which I don't know. I can multiply both sides by CA and then divide by sine of 34. Like we've been doing. And we have CA is equal to 5 divided by sine of 34. When I put that into my calculator, I get 8.94. Why the difference? Because you see right here how it's about equal to 34. See, this is not exactly 34. And so when I start to put in the sign of 34, I get a little bit of an imprecise answer. So here's what it should actually look like. When I got this, this is the calculation that I used. And so if I substitute that in for sine 34, look at what happens. CA really equals 5 divided by the sine of the inverse tangent of 5 divided by 7.5. Because if you'll recall, this is where I got 34 from. So that's where I got that about 34 from. Well, if I take the sine of the inverse tangent of 5 divided by 7.5, and then I say 5 divided by that answer, 5 divided by sine of inverse tangent of 5 divided by 7.5, I get 9.01. That is based on the actual measurements for that angle, not necessarily this thing that I've rounded. So what would I do in this case? Ideally, you do this. But this works also. Let's do another one. I've got it highlighted, so if you want to try it, you can do it. But I'm going to go through it right now. So if you want to pause it and try it, go for it. If not, I'm just going to go straight to it. We don't have two sides this time. We have an angle and a side. In some ways, this is different, but it's the same still. We still want to find all the 6 pieces. So we want to find all the unknown measures. That means sides and angles. Angle D should be fairly easy to find because I've got 180 minus 90 minus 58, and that's going to give me 32. So that's 32 degrees. I have everything that I need to start out this problem, right? Let's see. I know that I have the side opposite of 58. I need the hypotenuse. So if I recall, SOHCAHTOA, if I do the sine of 58, I can set that equal to opposite over hypotenuse, and I could solve that. Is there another way to do it? Sure there is. What if I did the cosine of 32? That would be adjacent over hypotenuse, so it would be 14 over FD. And so I have options here. Also, or I could set up the tangent of 32 is equal to EF over 14. Or I could set up the tangent of 58 equals 14 over EF. I hope that you see how many options I actually have. I just need to solve a couple of these to find one for EF and one for FD. Look at how this works. If I multiply by FD on both sides, I think you're going to see what's happening here rather quickly. FD sine 58 equals 14. I divide by sine 58. So FD equals 14 divided by sine of 58. 14 divided by sine 58 is about equal to 16.51, because I'm rounding it to the nearest degree, sides to the nearest hundredth, so that's tenths, hundredths. You might be tempted to use Pythagorean Theorem here, but remember, we're using a rounded value, so you don't necessarily want to do that. I'm going to solve one of these other ones for EF. Tangent of 32 is equal to 14, or EF over 14. So I'll multiply by 14. So 14 tangent of 32 equals EF. Calculator. So EF rounded is 8.75. Notice what I found. EF, FD, and this angle, which were the 1, 2, 3 pieces that were missing. That's how you solve for the missing pieces of a right triangle. I hope that you have seen how this works enough that when we move into the coordinate plane on this next one, you can do this. It's the same. It's the same, it's the same, it's the same. We're just putting things in the coordinate plane. Let's plot these points. J, -1, 2. K, -1, 3. Oh, -1, -3. Good. I was thinking, man, that's awful close. Okay, and L is 3, -3. Okay, let's look at how this ends up. When I connect the dots, and it's very sloppy because it's hard to draw straight lines with this thing. I have a right triangle here, and so when I'm going to find all the side lengths and the angle measures, I already have one. So let's list them out. Angle J, angle L, angle K, and I have 3 sides. I have JK, but I'm serious. KL and JL. A couple of these things are fairly easy to find. Angle K, 90 degrees. Right off the bat, boom, got it. What about JK? It's 1, 2, 3, 4, 5. And KL is 1, 2, 3, 4. I'll go ahead and list those. So this is 5, this is 4, and that's 90 degrees. Let's look at what we've got. We are going to use the same sort of principles. I'm going to use something to find JL. I'm going to use the distance formula. So JL equals the square root of. Now, if you recall the distance formula, we're going to plug in these points. 3 minus, and take note, I'm using L and I'm using J. 3 minus a -1 squared plus -3 minus 2 squared Look at what happens. I've got 16 and I've got 25. So 16 plus 25 equals square root of 41. So that gives me about 6.4. That's my other side length. About 6.40. How do I use the side lengths to find the angles? Trig ratios. use the formula, use the formula, use the formula. Now, to find L, angle L, let me move this up just a little bit, give myself a little bit more workspace. Angle L equals, notice what I've got. I have this side over here and the 4. I want to try to use sides that are not rounded. Avoid the hypotenuse because it's rounded. Use the ones that are not rounded. So angle L. The tangent of L is equal to the opposite over the adjacent. 5/4. Terrible 4. I'm having trouble with the 4s today. 5/4. So when I take tangent inverse of 5/4, that's actually going to give me what angle L is. Calculator. Tangent inverse. Turn it on first. Tangent inverse. 5 divided by 4 equals about, rounded to the nearest degree, about 51 degrees. So that means angle L is about 51 degrees, so that gives me 39 for angle J. Could I have selected other ways to do this? Absolutely. There's a lot of different ways to do each piece of this problem. But what I need you to understand is a couple of things. Don't round until the end. And try not to use a rounded value. So, here are our principles. Don't round until the end. Try to use whole numbers to calculate. Don't round until the end, and try to use whole numbers to calculate, ones that have not been rounded. Okay, guys? Here's one for you to try. I'd like for you to try it. We'll talk about it in class. Remember those principles. Don't round until the end. Try not to use rounded values. Alright, guys? Thanks for watching. We'll see you next time.